Okay, you guys, what I'd like to show you in this video segment is how to do types of reactions. Last unit, we talked about naming all sorts of different compounds, ionic, covalent, polyatomics, and now we're going to take those and put them into scientific equations. So if we take a look at this, chemical equations, we see equations in math class, but in science they look drastically different. It's an equation nonetheless, they just look different. And so here's what we have, our basic terminology here. On the left hand side, on the left hand of the arrow, we have the reactants, and on the right hand side we have the products. And in math class we would normally see an equal sign. In science we see an arrow in the middle, and that means to make, or it also means to yield. Yield, yes, I know that means slow down when you're driving, but it also means, in terms of these reactions, it means to make or to produce something. And so that's a little different than what you're used to, but we can sure use it here. So that's just basically what it looks like. Reactants on the left, products on the right, with the yield arrow in the middle. And so here's an actual chemical reaction. Here you notice it shows that we've got the reactants over here on the left-hand side and the products over here on the right. So we have H, and in this case we know what these things are. H is hydrogen, Cl is chlorine, oops. And we named this before. Hydrogen chloride. And so we've seen that part before. We don't call it hydrogen chlorine. We change that ending to chloride. And so the two reactants come together to yield. Again, we do not use an equal sign in science. We use the yield arrow. And so those two reactants come together to yield hydrogen chloride. And so now what we'll do, scientists have taken a look at different reactions, and they've realized that there are just some different examples of chemical reactions, and we're going to take a look at 5 of them, and our goal is to hopefully be able to identify those 5 reactions simply by looking at them. The first type of reaction that we will take a look at is a synthesis reaction. And so synthesis simply means to make. And so in this case, we take 1 or 2 or 3 pieces and add them together. And so the way we'll see them as we're looking at these, we see this generic form, some element or compound A, some element or compound B, joins together. The idea here, A starts out separate from B, and they're joined together to form something AB. And so when we put this into practice, we look at this, Li plus O2 yields 2Li 2O. What I'm going to do, you guys, I'm going to get rid of the stuff we're not ready for yet. This 2, don't let it confuse you. I'm going to get rid of it. This 2, I'm going to get rid of it. Don't let it confuse you. And this 2, don't let it confuse you. So now I have lithium plus oxygen yields, remember. And then we've already done this before. We've seen the lithium oxide. And that last 2, remember this. Remember our crisscrossing, we do know why that 2 is there. And so that's why there are 2 Li's, because we already practiced our crisscross. We've seen that, we know that. And so that's a little bit about this reaction. But bottom line, right here, that generic form, A plus B yields AB. That's a synthesis reaction. Here's another example of it. The picture is kind of silly, but it's right here, the bird. I think these are supposed to be its ribs. It's so hungry we can count its ribs. Well, then the bird eats the worm, And now we have this big, plump, juicy bird. So that idea of synthesis, they combine together. Again, up on top, here's our actual reaction. I'll get rid of the numbers we're not ready for. Hydrogen plus oxygen. And this is covalent. Hydrogen dihydrogen monoxide. Again, we've named that, we've seen that before. So part of this we are familiar with. The numbers that I've scribbled out, we will get to them, you guys. They will hopefully make sense by the end of this unit. But for now, I'm just removing them because we're not quite there yet. That's a synthesis reaction. Decomposition is the opposite. It means to break down. Means to break down. So this is a reaction in which one or more reactants breaks down into two or more products. And so here the generic A and B are together, they're bonded, and then we see the arrow. And now A is separate from B. We see that because the plus sign is in between, so we know that A and B are now separate. And so we look at the example, NaCl. We've already named that sodium and chlorine. We would call that sodium chloride. I'll get rid of that too. We're not quite there yet. Get rid of that too. Get rid of that too. We're not quite there yet. And that breaks down to notice my ending. I went back to chlorine. Remember, we changed the ending when it combines with something. Well, now the chlorine is by itself, so I go back to calling it chlorine. So to break down, it started as sodium chloride, and then it separated into those two pieces. That's decomposition. Again, here the picture, it's kind of silly, but here's the picture. They're both together. There's something inside the egg. Well, that reaction occurs, and now we have the egg plus the turtle. So they separated. And up here, get rid of that. Again, get rid of the numbers we don't need. And we see that again, dihydrogen monoxide. We got used to naming that last time. And then we've got the hydrogen and the oxygen. So they're over here, they're together. And then over here, notice they're separated by that plus sign. They're not together anymore, and that plus sign tells me that they're separated. That's decomposition. Our next type, single replacement. Single meaning one element replaces another. Before we look at the last one, notice A and B are together, and C is all by itself. And so what happens with this one? The C is going to come over here. It's going to push out the A. And so now notice A is by itself, C and B are together. So one element got replaced by another. So the A got pushed out and it got replaced by the C. And so we look at this one. We have copper oxide plus hydrogen. And now notice the copper is by itself. Also known, of course, as. So notice the hydrogen came over, pushed out the copper, replaced the copper. So we call it single replacement. Only one thing got replaced. And so we have copper oxide plus hydrogen yields copper plus dihydrogen monoxide, also known as water. Single replacement. Picture here, this guy, this strapping young lad here is all by himself. These two showed up together. Something happened at the dance. This guy's now by himself. These two are together. So one item got replaced. Poor guy had to go home alone. But here we see that Zn, zinc. And there's the hydrogen chloride together. Well, the zinc comes over, bumps out the hydrogen. And now the hydrogen is by itself. These two are together. So one item got replaced. Number 4, double replacement. double meaning two, and there it is, two elements get replaced. And so notice here what we've added. Notice that A and B are combined, C and D are combined. And what happens with this one? Let's see here, the B comes over, knocks out the D, D comes over, knocks out the B, and so now notice it's A and D together, C and B are together. So two things get replaced in this type of reaction. And again, this one's really busy. There's a lot of stuff going on, but notice A and B, we have lead chloride, PbCl is lead chloride, and then we have lithium sulfate. Again, this is a really busy reaction, but by the end of the unit, it will make sense, so don't get too overwhelmed if you are currently confused. But notice how this SO4 as a unit comes over, bumps out the Cl, and then the Cl bumps out the SO4. So where the Pb originally started with the Cl, it now ends with SO4. The Li started with an SO4, and now it ends with a Cl. Two things got replaced, so we call that double replacement. And here again, the only picture that I could find was the swapping of the hats. Two things got replaced. Here, this NO3 comes over, bumps out the Cl. The Cl goes over and bumps out the NO3. So the Ag started with NO3, but it ends with Cl. Na started with Cl, and it ended with NO3. Again, two things got replaced. Last one is combustion. Combustion, anything that's reacting with oxygen. So this is a type of synthesis reaction. Remember, synthesis looked something like that, but one of the reactants has to be oxygen. And so instead of B, notice oxygen has to be there because one of the reactants has to be oxygen. So some element or compound A reacts with oxygen, and then they combine to form some new product. We call that combustion. And so here in this case, A, this is what we call methane, carbon tetrahydride. Oops. Oxygen, so there's my A, there's my A, there's my O, and it yields some product. Carbon dioxide, does it matter that there is another product? It does not. This is still a combustion reaction because we have that oxygen in the reactant side. Anytime oxygen is reacting as an element on the reactant side, we call that combustion. Those are the 5 types of reactions that we're going to take a look at.